Hello, Algebra 2 students. Today we are moving on to 0.10, which is on solving systems of equations and inequalities by graphing. This is going to be very similar to, I believe it was our 0.8 lesson where we graphed equations and inequalities. And so if you have that down, this should be a really simple lesson. If you don't have that down, this will give you more practice with it because basically it's just doing that just more than once. Okay? So let's get into it. So first of all, we're going to be dealing with systems of equations here for this lesson and next lesson. And so we need to make sure we know what a system of equations is. So a system of equations is a set of two or more equations with the same variables. So this would be a system here. I have a set of two equations, y equals 3x minus 1, and y equals negative 1 half x plus 6. And they have the same variables. They have y and x. Okay? Now, we are going to be solving these. In other words, we're going to be finding the solution to these. And what you need to keep in mind with these is that the solution to these systems of equations are ordered pairs. They're an x-y pair. And it is the ordered pair that works in both of these equations. And what I mean by that is if I were to take this and plug it in for x and y, it would work in both of these. So if I plug this in to the first equation, our y value is 5, our x value is 2. We have 5 equals 3 times 2 minus 1. Well, that's just 5 equals 3 times 2 is 6, minus 1 is 5. It works there, right? We get that the two sides are equal. All right, if I do that to the first one, it works. And then if I did that to the second one, it should work as well. Let's see, we've got 5 equals negative 1 half times 2 plus 6. All right, that was our second equation. Just put the x and y in. Let's see, that's 5 equals negative 1 half times 2 is just negative 1 plus 6 would be 5. It works there as well. That's what a solution is. It's that ordered pair that when I plug it into both of them, I get something that works out, where I get the two sides are equal to each other. Okay? Now, I'm not really going to have you guys do this right here, but that would be a way to check your answer, is just to plug this in for x and y into each equation, just one at a time, see if they equal. What I actually am going to have you do is be finding that answer. Find that ordered pair that would work. And today we're going to do it by graphing. All right, so let's see how we do that. Here I've got a system of equations. We want to solve this by graphing, so I have a coordinate plane here. And basically what you got to know is to solve a system of equations, all you got to do is graph both of the equations on the same coordinate plane and then figure out where do the lines cross. Because that point where they cross, that's the solution. So let's look at this one. Here I've got y equals negative 2x minus 1 and y equals x plus 5. We're just going to take these one at a time and we're going to graph them. So I take the first equation and I'm going to graph it. My y-intercept is negative 1, my slope is negative 2. So we go on the y-axis to negative 1, put a dot, right? And then we use our slope. Remember, negative 2 would be the same as negative 2 over 1. And so that'd be down 1 and to the right, down 2 and to the right 1. So from this y-intercept, I go down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. We could also go the opposite way, up to left 1, like that. Right? And I'm going to put a lot of dots on here because I want to make sure I know where they cross. So put those down and draw on our line. All right? Then we want to do the same with the second one. Y equals x plus 5. So this one, we have a y-intercept of 5. We put that down. And then our slope here, well, x, remember, is the same as 1x. And so our slope would be 1 over 1. And so that's up 1 to the right 1. Up 1 to the right 1. Or remember, we could go in the opposite direction. We could go down 1 to the left 1, like that. Down 1, left 1. Just keep going. And actually, I don't really need to keep going because what do we have? Well, I can already see where they cross. Right? These two lines, they cross at this point right here. All right, and so that point, let's see, the x value is -2, the y value is 3, and so our solution is -2, 3. And that's all you have to do. Take your equations, graph them both, and then find where they cross, write that answer. Okay? That's simple. All right? And so, like I said, if you guys are good at graphing, if you had the graphing down, it is really straightforward because that's all you're doing. All right? Now, we do need to talk about a couple special cases. Sometimes when you go ahead and graph these, you are going to end up with two lines that are exactly the same. Basically, they just overlap each other everywhere. Well, if that's the case, what we say is that there are infinitely, all right, I'm taking my time here to make sure this is neat. There are infinitely many solutions. And we say that because remember, the solutions are where the lines cross each other. Well, if it's the same line, they are crossing each other everywhere on that line. And so there are infinitely many solutions. There are solutions every single place on that line. Okay? Then you might have another case where the lines are parallel. Well, if that's the case, I think we probably can guess what's happening here. Remember, the solutions are where the lines cross. Well, if they're parallel, they never cross. And so if that's the case, we say there are no solutions. All right? And so that's your two special cases. You might see them. If they're the same line, infinitely many solutions. And if they're parallel, there are no solutions. One more thing to look at, and that'll be it for this lesson, is you're also going to be given systems of inequalities. So now, instead of having an equal sign, we will have an inequality sign. And remember, the difference with graphing these is that first, we have to decide between a dotted and a solid line. So remember, if we have the equal sign on there, so it's a greater than or equal to or less than or equal to, that's a solid line. If we don't, it's a dotted line. Okay? And then the second thing we need to worry about is shading. And that's going to be a little special now, okay? But we'll see how that works in a second. So, basically, we're going to do this the same way. We just go through, we graph these one at a time. So this first one, y is less than 1/2 x minus 3. We start with our y-intercept. It's -3. Put that down. Then our slope is 1/2. So we have a rise of 1, a run of 2. So we'll go up 1 to the right 2. Up 1 to the right 2. And I can just kind of fill this in. We could go the opposite way, down 1, left 2. Like that. All right? Then we got to put in our line. Well, remember, if we don't have the equal sign, which we don't on this one, it's a dotted line. And so we'll go ahead, we'll put a dotted line down. And then we need to shade. And remember, with shading, what you do is you look at the y and you ask, is y the bigger one or the smaller one? Okay? Well, in this case, the pointy end faces the y, so y is the smaller one. That means we're going to shade below. But when I shade this time, I'm not going to do it very dark. I'm just going to do very lightly just to show, okay, for this line, we're shading below. Okay? So I just have some shading down there. I'm going to do it very lightly, and you'll see why in a second. All right? So we have that first one graphed. Now let's do the second one. So this one we have y is greater than or equal to -x plus 2. Our y-intercept is 2. So we go on the y-axis to 2, put a dot. Our slope, well, -x is the same as -1x. And so our slope is going to be -1/1. So we could either go down and to the right. So down 1, right 1. Just keep going. Like so. or we could go up and to the left. All right, and so we put all our dots down. And then this one does have an equal sign, so it's going to be a solid line, like so. And then we have to do our shading. We look at the y. In this case, the open end faces the y, and so y is the bigger one. We need to shade above. And again, I'm going to kind of do it lightly. I'm not going to do it really dark. Just like that. All right, then what I want you to notice on this, because we have one more thing to do, and this is kind of the added weird thing with this one, is that we've actually kind of divided this coordinate plane up into 4 parts, right? We have our 2 lines here, and it's kind of divided it up into 4 parts. We have a part right here, right? A part down here, a part down to the right here, and a part up here. Only one of these sections, one of these 4 sections, is where our solutions are. All right? And we need to figure out which one that is. And to figure it out, you need to figure out which of these sections does the shading overlap. So we shaded for the purple line down here. We shaded for the blue line up here. And where does it overlap? Well, it definitely doesn't overlap on the left-hand side because we didn't shade there at all. Down here, it doesn't overlap. That's just the purple line. Up here, it doesn't overlap. That's just the blue line. It overlaps right there. That's the only part that we have both purple and blue. And so what I want to do at the end is I want to go back and I want to shade that extra dark because that is where our solutions are. Okay, and it's a little messy on here. It's a lot nicer with pencil where you can shade it really nicely, but that's the idea. Okay, you just graph both of these, shade lightly right away because we don't want to we want to make it clear where we've shaded and where we haven't, and then find the region. There will be 4 of them, right? Find the one where they overlap. And that's what we're doing today. So, you're going to have some problems where it's just a system of equations, graph the 2 lines, see where they cross, and you'll have some systems of inequalities. Graph them, makes you worry about dotted or solid lines, shade, and then see where the shading overlaps. In that region where it overlaps, you need to shade extra dark. Okay? So, if you have any questions, please let me know. Otherwise, just get going on the practice quiz and practice problems. This really should help us out. Like either you've got graphing down and you're good and this should be great, or if you need more practice with graphing, this should help a lot because you got to do more practice. So let me know if you have any questions, and one more lesson to go for this week. Let's make sure we get that done, and then let's be ready for the test on Friday.